So for this last sequence, let me see, there's not a common difference because this would be 2, 3, 4. Let's see if there's a common ratio. 3 divided by 1 is 3. 6 divided by 3 is 2. So there's not a common ratio. There's not a constant difference. So it's neither arithmetic or geometric. And I could probably figure out the next two terms. Let's see, this is plus 2 plus 3 plus 4. So the next term will be plus 5 and then plus 6. But I can't write a formula for it. Let's go on to example 3. The second term in a geometric sequence, so I know it's geometric, and they told me that the second term is 20, so g sub 2 equals 20, and the fourth term in a geometric sequence is 80/9, so g sub 4 is 80/9. Find the first term and an explicit formula for the sequence. All right, so what I'm going to do is I'm going to use my calculator. The second term is 20 and the fourth term is 80/9. I'm going to rewrite these as ordered pairs, 220 and 4 80/9. And I'm going to go to my calculator. I'm going to go to Stat and Edit. And what I already put this in, 80/9. I converted it to that. I put those ordered pairs in, and because it's geometric, that means it's going to be exponential, because you know how up here geometric sequences have a starting term, common ratio to the nth power. This is exponential. So I'm going to go to Stat and Calc, and I'm going to go down to exponential regression. And I get y equals 45 times, I know that 0.6 repeating is the fraction 2/3 to the x power or to the n power. I guess I can use x. Now notice this is to the x, which means this is not the first term, it's the 0 term. So this right here is g sub 0 since this is x. In order to find the first term, I need to put a 1 in, so 45 times 2/3 to the first. So 45 times 2/3. And I get, so this is actually, I should say, this is g sub 1, and I got 30. So 30 is the first term. If I wanted to write my formula using this, I could have said y equals 30 times 2/3 to the x minus 1. So if I'm going to start with the first term, it's to the x minus 1. If I'm going to start with the 0 term, it's to the x. Now I've got this table where I'm going to compare arithmetic and geometric, because in the last section we covered arithmetic, in this section we're covering geometric. Arithmetic is a sequence in which there is a, let's see, between consecutive terms is constant. There you go. I'm sorry, I just was trying to find my words. A sequence in which the difference, I wanted to use the definition from the other day. A sequence in which the difference between consecutive terms, consecutive means in a row, consecutive terms is constant. A sequence in which the difference between consecutive terms is constant. So geometric is a sequence in which the ratio between consecutive terms is constant. So remember, I have term minus previous term. Here I have term divided by previous term. My terms I add to get to the next term. And here I multiply to get to the next term. Now, remember, adding a negative is when it gets smaller. Multiplying by a decimal makes it get smaller. We don't say multiply or divide, we just say multiply. And we don't say add or subtract, we just say add. And maybe you add a negative. My explicit formula is a sub n equals my first term plus that constant difference times n minus 1. And for geometric, g of n equals that first term times the constant ratio to the n minus 1. Or g sub n can be the 0 term times r to the n. Recursively, a sub 1 is the first term. And a sub n is the previous term plus that constant difference. And for geometric, g sub 1 is the first term. And g sub n is the previous term times the constant ratio. Sometimes we have a sequence that might look like a fraction. And it says find an explicit formula for the nth term of this sequence, 1/3, 2/5, 3/7, 4/9, 5/11, 6/13. What I want you to do when looking at this sequence is don't look at the fractions as the whole fraction. Treat the numerator and denominator as separate sequences. So treat the numerator as a sequence and treat the denominator as a sequence. So think of just my numerator. The 1, 2, 3, 4, 5, 6. I'm adding 1 to previous term. And on the bottom, 3, 5, 7, 9, 11, 13, I'm adding 2 to the previous. So let's write an explicit formula for the numerator. 1 is the first term, plus 1 times n minus 1. My denominator starts at 3, and I add 2 times n minus 1. And now I just need to simplify my numerator and denominator. 1 plus, when I distribute, I get n minus 1. When I distribute this 2, I get 3 plus 2n minus 2. When I simplify, the numerator becomes n, and the denominator becomes 1 plus 2n. And there is my explicit formula. A sub n equals n divided by 1 plus 2n.